ठीक है, बोर्ड ठीक आ रहा है, क्लियर है। हाँ जी, चलो तो once again, good morning to all. In class we have already gone through the particular terms related with the spherical mirror. Now we are simply discussing a spherical mirror. Take care. So we had gone through this topic and some related terms we had already faced. And after that we are entering in the term reflection. Laws of reflection, whether it is valid for a spherical mirror or not. So in the case of a spherical mirror, we have to see that laws of reflection of light. So we have gone through the rules for drawing the ray diagram. 4 rules were there, and during that case we had also shown how can we draw the normal for a spherical mirror, and then we had also shown angle I is equal to angle R in all the 4 cases. So once again we will move from there and then we will further proceed. Okay. So first see the first law, that this is the concave mirror P, F and C. First rule, light ray parallel passing through the focus after reflection. First see. This is the first rule, when the light ray will come parallel to principal axis after reflection it will move to the focus. In this case we had shown this is the point of incidence. So when you will join this with center of curvature, this CM, this CM will behave like the normal. We have shown why we can define or we can treat this as normal. So in between the class you are just joining, so I am getting some trouble to provide you allowance. So just join the class within the time. Just see diagram, very simple diagram is there. So this is the first, this when you join the point of incidence to the center of curvature with a straight line, it will behave as a normal. And this is the angle between normal and incident, I. And this is R. So here angle I will be equal to angle R. So it means law of reflection of light is valid for a spherical mirror also. This is the first case. Now for convex mirror, just see. This is convex mirror F C P. Here again it is parallel. As per the law, it will move away from focus. Just see. This is simply first. Now, this is the law, light ray parallel to principal axis after reflection, moving away from focus. Now, this is the point of incidence, M. Once again, CM is behaving as a normal. So, when you will join this point to the center of curvature with a straight line, it will be treated as normal. So, now we are just joining. Just see. So this is normal. So this is again incident ray, normal angle I. This is angle R. So once again here you will get angle I angle R. So first law or first rules is also supporting the law of reflection of light. This is the first case in which light ray parallel to principal axis passing through focus or appear to move away from focus. In both cases you can see this angle I is equal to angle R. Okay. So only you have to practice the diagram. You need to practice the diagram at home. Then you will be able to draw any type of the diagram. All the diagrams can be drawn just using the 3 rules or 4. I had told you, I had explained 4 rules. So we have just explained them. Okay, this is the first case. Now come to the second case. Second case for both concave as well as convex. First, this is concave. This time just opposite. This time not parallel. This time the light ray will come from focus, then it will go parallel to focal axis. Just see, there is the exchange. There is exchange of incident ray and reflected ray. In first case, this was incident ray. Now it is incident ray. It is reflected. So once again, this point will be M. This will be normal. So only angle will be changed. This is incident, but this will become R. This will be R. Once again, angle I is equal to R. Okay. For convex mirror, when you will join the line, this is F, this is P. This time, here the light ray is passing through focus, but you know, convex mirror has virtual focus. So directly light ray will not pass through focus. It will directed towards the focus. It will appear to move towards the focus. The light ray is coming just appearing or seems to move towards focus. So what will happen? After here, it will become parallel to principal axis. See. So what will happen this time? This point of incident. So again you will join this line, just this CM normal. So this will be I and this will be R. Once again angle I is equal to angle R. When you will measure both the angle, you will get both are same. So just you need to practice at home. When you will practice yourself, just I am telling you, when you will practice yourself, it will be very simple. And I am just drawing the diagram freehand. If you will use the measurements, then you will automatically get which two angles will be of same length. Okay. So two, now third and finally the fourth. So the third point, when the light ray passes through the center of curvature, this is the third case. In the concave mirror, this is P, this is F, and this is P. This time, both the diagram will draw. Light ray will pass through C. Just see. Light ray is passing through center of curvature. In this case, we had shown light ray will simply retrace its path, return to the same path. So light ray will return to the same path. So just think, how can we show that angle I and angle R is same? Here incident ray and reflected ray both are same. Both are coinciding. So same line is behaving as incident ray as well as reflected ray. So how angle I and angle R will be shown? So once again, this is also point of incidence. So this is three common lines. Incident ray, reflected ray as well as normal also. So when two lines ray will coincide with each other, what will be the angle between them? 0 degree. So just see here, angle I is equal to angle R, both will be equal to 0 degree. That's why we are showing here angle 0 degree can't be shown, overlapping. First line, second line. So the angle between both lines will be 0. This is incident ray, this is normal. This is reflected ray, this is normal. So angle between both will be 0. So we can write like this. Now for convex mirror, just see, this is focus, this is center of curvature, this is P. Now see, now I am just removing this. I am writing here angle I is equal to angle R barabar. Now here you need to pass through C. This light ray is just appearing to move towards C. It will simply reflect like this, and this is point of incidence. So once again, angle I barabar angle R is equal to 0 degree, because this light ray is incident ray as well as normal. So it is also normal. Is there any problem? Then you can write any problem to anyone. You will simply ask in the live classroom, in the offline classroom also. फिर से बोल रहे हैं जी, किसी को किसी तरह का कोई डाउट होगा क्लासरूम में पूछेंगे, तभी हम लोग आगे बढ़ेंगे। एकदम ध्यान देना है, कभी भी कोई डाउट हो पूछ के ही आगे बढ़ेंगे। तो दिस वाज द थर्ड, नाउ द लास्ट वन, that is the case number 4. This is for concave mirror. Now light ray is directly incident on pole here. The light ray is coming and incident at pole. So this point is also point of incident. So when point of incident is joined with it behave like the normal. It means this principal axis is behaving like the normal. So angle between incident and normal will be regarded as angle I, and as per the law of reflection, just reflect back like this. And when you will measure this angle R, you will get angle I and R to be same. It means when the light ray directly incident at pole, it reflects back as per the law angle I is equal to angle R. Now for convex mirror. This is focus, this is center of the vector, this is P. Now the light ray directly incident at pole. So this point is what? Point of incidence joining with P. This is behaving as normal, normal, normal. So this is incident and normal. The light it will be turned back like this by making equal angle. Hence angle I is equal to angle R. Just see and have a look. If there is any problem, you can just raise your hand, then I will tell you, I will sort out your problem. Is there any problem to anyone there? Otherwise, I think already we have gone through these topics in the previous classes. These are the topics related with class 7. So I don't think that anyone has this type of problem. If have, you can raise your hand. No problem? Anyone? Okay, then I am moving forward. So after the law of reflection of light, our target is to obtain the various type of image. Image means whether it will be real or virtual. In the case of the spherical mirror. So till now we have gone through the image formation by the plane mirror. Now in the curved or spherical mirror, we have got two types of mirror. So we have to see how there is a change, how there is a variation in the nature, position, size of the image formed by the spherical mirror or concave or convex. So now one by one, our target will be to look after the characteristics. So what will be the positions of the object with respect to mirror? In the case of plane mirror, we have seen when we are in front of plane mirror, when we move away and toward the mirror, we have seen just there is a relative variation in the position. And now in the case of concave or convex, we have to observe and how it will be different from that of the mirror based plane. So first of all, we will see image formation in a concave mirror. In concave mirror, how many positions can be regarded? Anyone? How many positions can be considered? Just see. This is concave, na? This is concave. This is P. This is F. This is C. So, in theoretical view, we can put the object in between P and F anywhere regarded as one position. In between P and F, one position. Where is the object? In between P and F. Only one position. But numerically, if the value of this F from this distance, if it is 10, then in between 0 to 10, infinite positions will be there. So when you will solve numerically, you will have many options. But theoretically, only one option will be there, and the object is in between P and F, one position. Second, when the object is out at F, another answer will appear. So it is the second position. Third, between C and F. Fourth, exactly at C. Fifth, beyond C, out of C. And fifth, very, very far away, that is at infinity. So it will be the sixth position of the object. So in all these cases, we have to see how the image can be obtained, how the position of image can be obtained, what will be the nature of the image. So just one by one we will see. First case, when the object is at infinity. Object is at infinity. So what you have to do? Draw the diagram, write the nature, position and size. This is P, this is F, this is C. Infinity means if any object is at infinity, the light ray coming from infinity is considered to be parallel. So the parallel light ray is coming from infinity. These are the parallel light rays. It means what? Object is at infinity. And once again, many light rays can be there. Infinite light rays are coming. But for the formation of image, we have just explained at least two light rays should be there so that their intersection point can be obtained. And on that basis, we observe the position of image. So two light rays we have taken. You can take two, three, or some more. One more light ray I am taking. Now this is means object that. What will happen? Rule number one. If the light ray parallel to principal axis, after reflection, they will pass through focus. So all the light ray will pass through focus. Just all the light ray will pass through focus. So it means these light rays are actually intersecting. So image will be formed. Just see. So what will be the nature? Nature is real and inverted. After that, position. Where image has been obtained? Of course at F. And after the size. What is the size of the image? And how can we say that sir it is real and inverted? Inverted means उल्टा. तो हम लोग जब दिख ही नहीं रहा है कि इमेज बन रहा है डॉट है तो उल्टा है सर ये कैसे दिखा? So by the actual or apparent intersection, we have discussed in class. If there is an actual intersection, it is real. So actually the reflected rays are actually meeting. So on that basis we have it. And image size is dot line. Dot line is point size. Very small image is of point size. Point size means very very small dot like diminished. Okay, diminished शब्द कब यूज करेंगे जी? डिमिनिश्ड मीन्स इतना बड़ा इसके रिस्पेक्ट में इतना छोटा बनाइए डिमिनिश्ड. ठीक है, बहुत बड़ा रिस्पेक्ट में थोड़ा छोटा हुआ डिमिनिश्ड. लेकिन एकदम डॉट बना तो वो पॉइंट साइज. एक्चुअली इट इज हाईली डिमिनिश्ड. ओके, इट इज हाईली डिमिनिश्ड. यू कैन राइट highly diminished. Yes. So this is the first case. Now similarly second case, when the object is after infinity object, I am just moving towards the middle school. So after infinity it will beyond C, means beyond center of curvature. So just see, you need to understand the diagram. Don't need to learn, don't need to simply write the diagram. Diagram is just on the basis of the rules what we have discussed in the class. Only we have to follow the rules. Object, this time object is there, situated beyond. This is the object. Object is present here. This is the size. This time object is appearing. So rule number one, first ray, light ray parallel. First light ray parallel. So law, as per the law or rule, second, just see straight light. Rule number one, parallel passing through focus. Second, just the point after the object. What will be the first point after the object? We have to pass the light ray to that. So after this object, this point is also, this point is also, this point is also, but this C just after. So the second ray will pass through this. So as per the second, if the light ray is passing through, it will reflect back to the same path. So this reflected ray are intersecting here. So this is just P. Inverted image is being formed by the mirror. So this time inverted actual intersection. So this one will be real. So this time nature. Nature is real and inverted. Okay. And position just be between C and F. So the position will be between F and C, focus and center of curvature. And size, this time the size is diminished with respect to the size of object. See, size is this is smaller. Here it is point size, that's why I have highlighted. So this time you can write only size of the image is smaller in compared to the object. Okay, any doubt? No. So just you have to see. Okay. So some more participants need to join the class. These are important for you. I had just requested you all in the class also that these are the basic things. Thousands of diagrams can be drawn on the basis of 3 or 4 rules only. Don't think that so many diagrams can be remembered. No. Only we have to follow the rules, automatically diagram will be drawn. So just I am doing that. Nothing have been utilized other than the rules which I had explained in the class. So these are the 2 rules. Now, next question. These all conditions will be applicable during the solution of numerical. I am telling you again and again. Any numerical can be cross-checked or verified on the basis of these theoretical concepts. Any numerical, you can check whether the answer has been given wrong or right. You can check with the help of these because these are the basic things, very much important. Okay. So now the third position or third condition, we will move forward. So the third condition of the object position. Now this time, when the object is at C, this time object was beyond C. Now the object is at C. So just see how the diagram is drawn. Don't remember, just see how the rules have been followed. The object is situated at C, center of curvature. The first light ray will be parallel to principal axis. Rule number 1, passing through focus. Second, after this object, the just point is F. So this time light ray will pass through F. So rule number 2, light ray passing through focus become parallel. So this will become parallel. Here it will move parallel and automatically the image will be formed at exactly at C. So nature will be real and inverted. Just see. Position at C. Size equal size, yeah, same size. Same size. In first case, point size. Second case, diminished. Third case, same. It means as we are moving towards mirror, the size of image is growing high and high. Its size is increasing slowly. So this time it has become equal. It means in the next condition, the size will be larger. Just see the fourth case. Now, when the object is between C and F, between C and F. So now this time, this is the mirror and this is the position. This time this is the object. Here, this is the object. Now, first parallel passing through here. Second again, after this pointed here, it is also here. So passing through this, it will become parallel. And once again, I am telling you, never the any case will be repeated. If you are drawing wrong diagram, just see it again forming in between C and F. So already we have seen in between C and F in previous step. It means here the location is not equal this point same, then automatically this will be beyond. Just see, this will be beyond C because between C already. So again, nature will be real and inverted. Position beyond C and size, just see, the size of image is larger than object in this case. This can be written as enlarged or simply magnified. These are two new words, diminished for a smaller, enlarged or magnified for larger. If the in examination, if you forget, you can write, you can just simply write larger or a smaller word. But these are the technical words which have been mainly used in science or physics. So these are the fourth condition. Now, two more conditions are there. It may disconnect because 40-minute schedule is only there. So the fifth case, when the object is at F. F means focus. So what will happen? Just see. This is P, this is F, this is C. Now the object has been kept or placed on focus. First parallel, second base. So here two diagrams can be drawn. I am just drawing one diagram. Second case, P, so as per equal angle, if you move just one observe, this will be the parallel ray diagram. After reflection, parallel light ray will move. And you know, parallel lights never meet, but it has been considered that they meet at very, very far away, infinity. So when they will meet infinity, within or under the principal axis, it will be inverted. So it will be real and inverted. Position at infinity. Size enlarged, बहुत बड़ा. Enlarged or highly magnified. Is there any problem to anyone? Sir, on how, on what basis you have written real? Real means if they will meet at infinity very, very far away, the image will be formed under this principal axis, downward, and downward is inward. And the last case, when the object is between P and F. P and F. Now, just see. P, F, C. This time object is here. First ray is here. It will move through focus. Second, once again, P, it will move like this. Just see this time. These are parallel ray, these are not parallel. So it is diverging. They are moving away from each other. It means what? If they are moving away from each other, there is no chance of intersection. There is no actual intersection. So you have to proceed further in this way. This is the dotted line. Dotted line shows these are the virtual part. This is the virtual. Simply wherever you meet, this will be dotted line. Dotted. And this is the image. Just see, nature will be virtual and erect. इरेक्ट मीन्स सीधा, देख लो जी ऑब्जेक्ट सीधा, इमेज सीधा बना, उल्टा नहीं। पोजीशन, साइज, साइज इन लार्ज हो गया। पोजीशन मीन्स बिहाइंड मिरर, इधर कोई पॉइंट नहीं है कि बिटवीन बियॉन्ड बोले, सारे इमेज इधर थे अब इधर बने, तो मिरर के पीछे, बिहाइंड द मिरर, behind the mirror. These are the six conditions in which we have shown the image formation and nature. And yet remember, in 5 cases, real image has been formed. In 1 case, only virtual image has been formed. It means what? Concave mirror can form both real as well as virtual image. So just see how we have moved towards the mirror, then the size of image has grown larger. When you will move away from the mirror, size will decrease slowly. This is towards. When you will move away, slowly move very away or at infinity, size of image will be point size. So in concave mirror, real, virtual, both images will be found. Diminished, enlarged, same size, all type of image will be formed, and position of image will also be different in every case. Now, all the 6 cases we have to utilize in the case of convex mirror, whether it will be applicable or not. So these are the two diagrams which can be drawn into different way also. One more diagram I can draw for this and this also. Just see this diagram. I am drawing again this diagram, but answer will be the same. Just see. The same answer will be repeated. Only diagram will be changed. P, F, C. This is at F. First is here, passing through F. Second, not P. Second, this C. This C. Went through C, return to C. This is again parallel. So same answer will be there. Yes. This is the second method, second diagram, but the answer will not be different. Answer will remain same. Similarly, here you will again get second diagram. Just see. I am again drawing another diagram, but the answer will be same. So here P, F, C. Object is here. First ray passing through focus. Second, this C. Just see. This is diverging away. Just see. The divergence between both will simply increase. The light ray coming from here, divergence is increasing. So what you do? You will simply proceed in this way. This way. So this will be the diagram. So once again, answer will remain same. So different types of diagram can be drawn, but the answer will not change. So your target is to remind, to practice the ray diagram with the correct answer. These are the correct information regarding each and every case. If you will remember this, then only you can verify your numerical at the same time. क्लास में कोई न्यूमेरिकल बनाएंगे तो वहीं पर कंफर्म करेंगे, किताब में कुछ भी आंसर हो हम अपने आंसर को कंफर्म करेंगे कि नहीं मेरा आंसर सही है, किताब वाला हो सकता है गलत हो, उसके लिए क्रॉस चेक करेंगे, हो सकता है हमारी ही मिस्टेक हो और हम कार्यक्रम सही है, तो ऑन व्हाट बेसिस वी विल rectify or how will we cross check on this basis. These are the theoretical concepts. Okay, so you need to practice these diagrams. I will just call on the blackboard one by one for the practice of the ray diagram. Any condition will be provided to you and you need to draw the diagram and write the notification and size. So this will be practiced in the classroom when you will come in the school, means in offline class. So today's homework for you, only you need to practice the ray diagram for image formation by concave mirror in all 6 cases as well as before this we have also drawn the ray diagram of image formation for the plane mirror. So how the image is obtained in plane mirror. So 6 plus 1, 7 cases you need to practice at home and then in classroom we will practice. You will practice on the blackboard. I will call you one by one, and then you need to practice on the board. Okay. So today we will not finish the next topic, that image formation by conjecture. In next class we will finish the topic image formation by convection. Okay. So I think now I should finish the class. Now it will be already scheduled time. Okay. So good day to all. Thank you.